Introduction to Organic Families. In organic chemistry, the family has the same functional group. In order for that to make sense, we need to know what is a functional group. And you can see that the functional group is an atom or group of atoms that always react in a certain way in an organic molecule. Now today, for the introduction, we are not going to be looking at specific molecules and formulas, but we are going to be looking at the name of the family, the general formula, and the functional group. The functional group is the part of that family that makes it part of that family. Now before we start looking at the different groups, I'm just going to clarify something that we haven't talked about before, and that is using the notation R. Now this R could represent any alkyl group. So that means it could be representing a methyl group, which as you know is CH3. It could be representing a C2H5, an ethyl group. It could be representing a propyl group, C3H7. It doesn't matter what this alkyl group is. R1 is used to show that there could be two different alkyl groups. So this could be any other alkyl group. Now that could be the same or it could be different to that first one. It doesn't matter. So we could have two methyls, we could have a methyl and an ethyl. It could be anything. So starting to look at the functional groups, we're going to start off with the halocarbons. So halocarbons are named from this halo which represents halogen. And halogen, as I'm sure you can remember, is group 17 of the periodic table, which could be fluorine, chlorine, bromine, or iodine. Now, how does this fit into our group? Well, we're going to have our alkyl chain, that could be any length, and it's going to be attached to one of these atoms. It could be fluorine, chlorine, bromine, or iodine. But it's that particular atom that makes it a halocarbon. The next family we're going to look at is the alcohol groups. So again, we're going to have an alkyl chain, and this time what makes it an alcohol is the presence of an OH group. Now this OH group is called hydroxy. Hydroxy, of course, shows the hydro for hydrogen, oxy for oxygen. So hydroxy, OH group. Now an ether has an alkyl group attached with a single bond to an oxygen. But the important bit that makes it an ether is that the oxygen is on the other side attached to another alkyl group. And this could be the same or different. And we call this alkyl group, single bond oxygen, single bond alkyl group, an ether. So that's easy to remember because the functional group is the same as the name of the family. Aldehydes are an alkyl group attached to a carbon which is attached to a double bond oxygen, and then the fourth bond on that carbon is a hydrogen, and it has to be a hydrogen in order for it to be an aldehyde. The important bit about this though, the functional group, is the C double bonded to the oxygen, and C double bond O is called a carbonyl group. You do have to pay attention though, as I said, that other bond, the fourth bond on that carbon, is a hydrogen. Now aldehydes are very similar to ketones. Ketones equally have a carbon chain attached to a carbon and a double bond oxygen, but this time the other bond on that carbon is not to hydrogen, it's to a different alkyl chain. So that's why it's super important to pay attention to whether or not that fourth bond is attached to a hydrogen or an alkyl chain, because it makes it different as to whether or not it's an aldehyde or a ketone. Again, though, the functional group is the carbonyl, and the carbonyl is the C double bond O. Carboxylic acids again start off with an alkyl chain attached to a carbon with a double bond oxygen, but the fourth bond on this carbon is going to be a hydroxy group. So it's super important that you're looking to see that this middle carbon is attached to a double bond oxygen and the hydroxy group. It's the presence of both of those oxygens and the hydrogen that make it the carboxylic acid. And the functional group is the carbon, the oxygen and the hydrogen, and that is called carboxyl. Then we're going across to the Ester family, and the Ester family has the alkyl group attached to a carbon with a double bond to oxygen, and then another oxygen. But instead of being like the carboxylic acid attached to a hydrogen, we're going to continue now across to another alkyl chain. So the C double bond O, single bond O, is in the middle of two alkyl chains, and we call this functional group ester. Again, very similar to the carboxylic acid, C double bond O, single bond O, but another carbon group on the end. Finally, these next two both have nitrogen in. So amine and amide both have the presence of a nitrogen group. And amine is when we have an alkyl chain attached to a nitrogen and two hydrogens or other alkyl groups. It's optional this time. So this group is known as amino. And finally, the last one that we're looking at are the amides, when we have an alkyl chain attached to a carbon, double bonded to oxygen, then going across to the nitrogen. And we're going to have different alkyl groups attached to that amide. So the functional group in this case is called the amide. So the difference between the amine and the amide is the presence of the oxygen in the amide. Thank you.